All right, it's now time to learn about Hamiltonian paths and cycles. Before we launch into it, let's just write something down. So what we're going to write down here is that Euler is concerned about edges. And that's easy to remember because some alliteration really helps us out here. Euler is concerned about edges. Now we're going to learn about Hamiltonian paths and cycles. So this is named after a guy called Hamilton. And Hamilton is concerned with vertices. Unfortunately, no alliteration here. But in the back of your mind, this is what you need to keep there. Euler is concerned with edges. Hamilton is concerned with vertices. So let's now learn the difference between a Hamiltonian path and a Hamiltonian cycle. So let's go through our definitions here. A Hamiltonian path includes every vertex exactly once and starts and finishes at different vertices. It has no repeated edges and you do not have to use every edge. In contrast, a Hamiltonian cycle includes every vertex exactly once and starts and finishes at the same vertex. No repeated edges, do not have to use every edge. So hopefully you can note here that the only difference between a Hamiltonian path and cycle is that for a Hamiltonian path, you have to start and finish at different vertices, when for a Hamiltonian cycle, you have to start and finish at the same vertex. So this is the only difference. So we'll write this down. Only difference. So the only difference between a Hamiltonian path and a Hamiltonian cycle is where you start and where you end. A cycle has to end where you started, and a path has to start and end at different places. Okay, with that being said, let's now pause and go through some examples.